everyone, welcome back. In today's episode, we're going to plunge into a world that's already everywhere in our daily lives, even if we don't always notice it. Think about it. You're scrolling social media, you ask your virtual assistant something, your email catches spam. Yep, that's all machine learning. Powerful machine learning models are behind all of that. It's true, they are everywhere. But first, if like me, you're all in on AI, then smash that like button, smash subscribe. First part of this Edge AI, we'll talk about the cloud computing bottleneck. Despite the ubiquity of machine learning, there's a lot of really cutting edge machine learning stuff that's still stuck in the cloud. Why is that? Well, it comes down to computing power. These models need a lot of it. Just running them, doing the inference part, can get seriously expensive. So that kind of limits where you can actually use these powerful tools. That's the bottleneck. If we want machine learning to really spread out, to get into everything, we need a way for these models to run on small devices, things without massive power budgets. So enter TinyML. Precisely, that's exactly where tiny machine learning, or TinyML, comes in. It's a whole subfield that's popped up just to solve this problem. But before we go through it, and I just mentioned running inference, let's quickly unpack what that means. Inference is basically when a machine learning model, one that's already been trained, takes some new data it hasn't seen before and uses what it's learned to make a prediction or a decision. It's the model actually using its training in the real world, applying its knowledge. So it's the model doing its job. And our mission today is to unpack TinyML, to look at the benefits, find some cool real world uses, and get into some of the nitty gritty of how you can actually make it happen, the workflow. It's really about figuring out how this tech will let us do more with less. So, what makes it tiny? So, that sets the stage for machine learning generally, and let's focus on TinyML. Why is it tiny, and how does tinyml.org define it? Have a pretty specific definition when they say tiny machine learning is broadly defined as a fast growing field of machine learning technologies and applications, including the hardware, the algorithms, and the software capable of performing on device sensor data analytics at extremely low power, typically in the milliwatt range or below. So, milliwatts, yeah, that's tiny. And their definition continues. It says enhance, and hence enabling a variety of always on use cases and targeting battery operated devices. So, yes, really low power, extremely low power, always on. That sounds worlds away from the power hungry cloud models we started with. And it really is a different mindset. So what's driving the growth in TinyML? It's advances in both the hardware, the chips, and the software, the algorithms. These are improvements that allow us to put ML onto these low energy systems, things like tiny sensors, microcontrollers, those little specialized computer chips designed for one job using minimal power, the ones that power everything from your thermostat to wearables. And TinyML brings the intelligence right to the extreme edge, as they call it, right where the data is actually being generated. And that means you get real-time responsiveness. It's about squeezing the most capacity out of minimal resources, pushing intelligence out to the edge, and there are some big advantages. There's some real wins with TinyML. Number one is latency reduction. That's the first, and it's a big one. Latency means delay because the model is running right there on the device. You don't have to send data off to some server in the cloud and wait for an answer. Even small data transfers take time. Cutting that out makes the response almost instantaneous. And that's not just convenient, it can be critical for things where the milliseconds count, like real-time health alerts or industrial safety systems. Number two, energy costs and savings. Thinking about processing on device makes you wonder about the power use and needing the internet all the time. This leads straight into the next huge benefit, energy cost savings. Microcontrollers, which are kinds of the heart of many of these TinyML setups, sip power, like tiny amounts of power. So devices can run for ages, potentially sometimes years, on a single small battery. Imagine millions of devices out there just running, doing their job without constant recharging or main power. This drastically cuts operating costs. It's better for the environment too. And cost isn't just batteries because you're not constantly sending data back and forth to the cloud. You don't need all that massive, expensive server infrastructure on the back end. You save energy, you save physical resources, and you save money. And Number three is reduce bandwidth dependency, less charging, less server farms. What about needing the internet? Does TinyML cut the cord, so to speak? Well, it largely does, but that's the benefit of number three, reduced bandwidth dependency. For the actual inference part, making the prediction, you often need little or no internet connection at all. The device's sensors grab the data, the model processes it right there. So you're not streaming tons of raw sensor data, and that saves bandwidth. It also means these smart devices can work in places with flaky internet or sometimes even no internet at all. Think remote locations, agricultural fields, industrial sites. And coming in number four is enhanced data privacy. So privacy is a huge concern these days. Keeping data local must be a massive plus, right? Does this mean your smart speaker isn't sending recordings of you doing terrible songs to the cloud? Well, maybe yes. Your questionable karaoke choices could stay local. That's the fourth key, enhanced data privacy. That's huge. It really is. Since the model runs on the edge on your device and the raw data doesn't need to leave it for processing, the privacy guarantee is much, much stronger than otherwise. Your sensitive data stays put, avoiding the risks that come with sending it across the internet to servers somewhere else. So these benefits are really compelling. Low latency, low power, low cost, less network, better privacy. It sounds like TinyML is practically tailor-made for the Internet of Things. And you'd be spot on. Its applications are spreading everywhere. Yes, IoT is a natural fit. So maybe let's just quickly define IoT for anyone who's less familiar. The Internet of Things is basically the huge network of physical objects. It could be smart appliances in your home, industrial machines, even trackers on cows, all embedded with sensors, software, and maybe some other tech that lets them connect, swap data, usually over the internet, but sometimes just local. And within that giant IoT world, there are specific things that TinyML tasks that we see pop up. So things like simple computer vision, like detecting if a person is present, visual wake up words for activating a device, keyword spotting like, hey Google, Alexa, just making sure nothing went off. Also, predictive maintenance, listening for problems in machines, gesture recognition is another one. Basically, tasks that are useful but can be constrained enough to run efficiently on any small device. For some real world examples, we'll first look at agriculture. It could seem unexpected, but it's incredibly powerful in agriculture. TinyML devices are being used to monitor crops and livestock in real time. For example, Imagimob, a Swedish edge AI company, is working with the EU to use TinyML for really efficient crop and livestock management. Image sensors out in the field telling farmers exactly when and where to water or which specific plants need fertilizer. So maybe they're monitoring animal health signs continuously without needing someone physically there all the time. It's like giving every plant or animal its own little voice. Number two, industrial predictive maintenance. This sounds really obvious, like a really obvious win for saving money and the perfect fit. It directly hits those cost savings and uptime benefits. You deploy TinyML on these little low power devices attached to machinery and then listen. Essentially, yes, listen. They continuously monitor for subtle signs of malfunction, weird vibrations, unusual sounds, temperature changes, and these can predict various problems before there's a major breakdown. So that's clearly going to save a fortune. Huge amounts in avoided repair costs, and just as importantly, avoided downtime. There's a company out there called Ping Services. They made a device that just monitors acoustic signatures. They listen for sound, the sound of wind on turbine blades, They listen to the blade spinning continuously. If it detects any change that indicates damage, like a tiny crack starting, it alerts the operators immediately so they can fix it early and cheaply, reducing maintenance costs, lowering the risk of catastrophic failure, cutting downtime, and improving the turbine's performance. It's like machine empathy, understanding the machine's health. So, number three would be customer experience. Number three would be customer experience. How does TinyML fit there? Well, the customer experience now is so much about personalization, right? Businesses want to give you tailored ads, relevant messages. TinyML on the edge can help with that. By running models directly on your phone or device, an app can understand your context and your behavior without sending it all back to a central server. So it personalizes locally. It allows for potentially more fine-grained and timely personalization, maybe adapting the app interface or offering suggestions based on your immediate usage patterns, all while keeping more of your data private because it's operating on your personal device. Okay, so we've covered basically what it is, the big benefits, and we've gone through some cool examples of how it's used. So if you want to try this, what's the workflow for building and deploying a TinyML solution? Do you need a whole new set of tools? Not entirely. And that's the good news. A lot of tools, the architectures, the basic ideas come from traditional machine learning workflows. They still apply. The core difference isn't about totally reinventing machine learning. It's more about adapting and optimizing those models so they can run efficiently on really resource constrained devices. One of the most popular frameworks for this right now is TensorFlow Lite for microcontrollers, usually just called TF Lite Micro. TensorFlow. So basically, for microcontrollers, it's designed from the ground up to implement machine learning on embedded systems, devices that might have, say, a few kilobytes of memory, and it's really focused on an ultra low footprint, kilobytes. And Python is still often the go-to for actually building and training the initial model, just like regular machine learning development, but TF Lite Micro gives you flexibility for deployment. It makes it pretty straightforward to develop and then deploy your models using C, C++, or even Java. And actually, you can deploy them to run without needing an internet connection on the device itself. And that's the key for these edge scenarios. C++, Java, languages common in embedded systems. So now you have the framework, you have the TF Lite Micro, you have the language. So what about the actual hardware? What kind of boards do you need to get your hands on to get dirty with this? You definitely need supported hardware. You just can't run it on any old chip. But the good news is the list of supported microcontroller boards is growing pretty steadily. Popular ones include things like the Arduino Nano 33 BLE Sense, which is quite accessible. There's the SparkFun Edge, several boards from Adafruit, and like their Edge badge or their TensorFlow Lite kit. There are other boards emerging. So there's STMicro's STM32 Discovery kits, boards for Himax, Synopsys, and Sony. Point is, the ecosystem is definitely maturing. It's becoming easier for developers to find hardware that's compatible and start examining and building things in the real world. It's about making these powerful capabilities accessible even with limited hardware resources. So winding down, let's look at the broader vision, which I think is pretty clear. TinyML makes it possible to add intelligence, real useful intelligence, to potentially billions of everyday devices. Think about it. Home appliances, industrial sensors, wearables, toys, environmental monitors, all sorts of Internet of Things gadgets. And it lets us do it without needing expensive, power-hungry hardware in every single device and without needing constant cloud connection, without relying on internet connections that might be slow, unreliable, costly, or just drain the batteries on our devices too fast. Avoiding that round trip to the cloud cuts out the latency we talked about. It brings the smarts, the processes right to where the data actually originates. It's about getting powerful results even in these very constrained environments. TinyML has been picking up steam. It's riding a wave of advancements in both hardware and software. It's letting us embed machine learning models directly into tiny, low energy systems. The benefits are pretty compelling. Like I said, you get the low latency, you save energy, you save costs, you get better data privacy as it's operating locally, and you're less dependent on network connections. It sounds like a powerful combination for developers in all sorts of industries. And maybe thinking about the future, if you can put all these intelligence into literally billions of devices and they don't need the cloud, TinyML isn't really just making your toaster smarter. It feels like it could physically change. It feels like it could fundamentally change physical environment, making it more adaptive, more context aware, an ecosystem that responds locally, anticipates what you need. So imagine a pervasive layer of intelligence woven right into where you live and work, always on, always sensing, always learning locally, acting locally. Not necessarily big, complex AI, but small, efficient intelligence everywhere, creating an environment that's truly responsive right there with you. That's the kind of future TinyML could help build, an environment that adapts to you rather than just passively waiting for commands sent via the cloud. And that's a pretty exciting prospect. What aspect of this pervasive layer of intelligence are you most excited or curious about? Drop a comment, smash the subscribe button, smash the like button. Until next time.